All right, good morning, good afternoon, good evening, whenever you're listening to this video. I appreciate you tuning in, and here's what we're going to be working with today. We're going to be talking about chords within circles. Now, you may be wondering to yourself, what is a chord? And I want to give you that definition to start off here today, and that's this. A chord is a segment, so you want to write that down for the key term here. A chord is a segment whose endpoints are on a circle. Okay, a segment whose endpoints are on a circle. Now, as you look at the picture up here, I'm going to go ahead and draw in two chords. The first one is kind of a newer concept to you, so I'm going to label that AB. That chord right there, we're going to be using those type of chords today. You guys are more familiar with the chords that pass through the center of the circle, which we call the diameters. Okay, so if I go ahead and draw a line from here, from here all the way over to here, label that CD, passing through point E, then you know that that chord right there, we're not just going to call it a chord, we're going to be specific about it, we're going to call it a diameter. Okay. Now, before we get going into the three concepts that will be true down here dealing with chords, you need to understand something or review something that we talked about a while ago, back in chapter 7, I believe. But that's this concept right here. If I go ahead and draw a circle, okay, and I label, the center of that circle, and let's say I go ahead and draw in a 90-degree angle. Okay. Well, what do we know about this arc? Well, we know that arc measure is also 90 degrees. Okay. And so I want you to remind yourself, or even to write this down at the top of your paper, that the arc measure is equal to the central angle of a circle. Okay? So keep that in mind as we start to look at these three new concepts from today's lesson. All right, so for the first one, I'd like you to fill this in within a circle or in congruent circles. Now, when I say congruent circles, what I'm referring to are circles with congruent radii, okay? So you might want to make a little note of that off the side. In fact, I want you to show that congruent circles have congruent radii. We can say congruent diameters, but usually we say congruent radii. So number one, the first concept is this. Within a circle or in congruent circles, congruent central angles have congruent chords, okay? And so as you look off to the side over here, actually, you know what? I'll draw it on this page right here, okay? You may want to go ahead and draw this circle. Okay, that circle there on a piece of white paper, just so you have something to reference here. But here's what I want you to see. If we have congruent central angles, so let's go ahead and do something like this. I'll just draw in two diameters here. Okay. One thing I know is my central angles are congruent to each other. Okay. I also know that this length and this length and this length and this length have to be the same because they're all radii. So if I go ahead and draw a chord that connects this point to that point and this point to this point, what do I know about these two segments? Well, these two triangles in general are congruent by side angle side. Okay? And so as a result, those two segments, this one here and this one here, have to also be congruent by CP/CTC. All right? And so whenever you have congruent angles, you also have congruent chords. Now, the next one, if we look there, let's skip down to number 3. As you look at number 3, it says this: congruent arcs have congruent central angles. This is actually a concept that we talked about just a moment ago, in the fact that if I have a circle, or that was a bad circle, let's try again. I'm not sure if that one's much better, but it feels better. Okay. I can put these in two separate circles. I'm just going to work with one. But if I go ahead and, let's say I draw a diameter all the way across here, okay? And I'm going to go back to what we started the lesson with a 90-degree angle, okay? If I know that this angle is 90 degrees, then this angle also has to be 90 degrees, and the arcs have to be 90 degrees as well. Now, their lengths also have to be the same, all right? I don't know what their lengths are. I'd have to know what the radius is. It's really irrelevant, okay? And so as you look at number 3, congruent arcs have congruent central angles. I kind of went from the opposite end. I showed you congruent central angles have to have congruent arcs, but understand that they work both ways, okay? Now for the last one, congruent chords have congruent arcs. If I go ahead and draw that one, okay, so again, number 2, congruent chords have congruent arcs. I'll draw an entire circle again, okay? Here's my center. If I go ahead and draw 2 chords that are the same length, I'll say that one, and let's see here. I'll go with that one right there. It doesn't matter. I tried to make them as close to the same length as possible. So congruent chords, there we go, okay, have congruent arcs. Ooh. There we go. I don't know what just happened there, but I'm going to go ahead and draw in the radii here, noting that the radius always have to stay the same length. So those two are the same. Draw the radii in here. These two have to stay the same length, okay? Now, as a result, those two triangles are congruent to each other by side, 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 all right? And so the corresponding angles, this one and this one, have to be the same. Well, guess what? If those two angles are the same, if the central angles are the same, what do we know about these two arcs? Well, they also have to be the same. And so I'm just going to go ahead and make a little mark telling me that those arcs are the same. So again, number 1, the first one, congruent central angles have congruent chords. Number 2, congruent chords have congruent arcs. And number 3, congruent arcs have congruent central angles. All right. Now, I like this picture because I think it illustrates what we're talking about here pretty well. If you want to go ahead and show at the top of your paper central angles, okay, chords, and then arcs, you can go ahead and show that they are all dependent upon each other. If one is true, they all are true. Okay? And that's just a little diagram that I think will help you. If you can remember that, play that back in your head, that will help you as you work through some problems that we're going to be looking at. Now, as we scroll down here, go ahead and do this. Here we go. Okay. If we take a look at number 1, I'm going to mark everything out that's true. We know we have congruent circles, so I'm going to go ahead and mark the radii congruent. Okay. I also know that I have congruent arcs, so I'm going to mark the arcs congruent. Now, as a result, if I have congruent arcs, I know that I have a congruent central angles, and so I can go ahead and mark angle PQR is congruent to angle STU. Okay, so those two are congruent. And I also know that if I have congruent central angles, I have congruent chords. So I can go ahead and mark PR congruent to SU. All right, so again, they all three play together as you're working through that. In this one, I have congruent circles, so I'm going to mark the radii congruent. I know that these chords are also congruent. Okay. Now, with congruent chords in number 2, if I look at my example or my rules up there, I know that I have congruent arcs according to number 2. So I'm going to put down BC, the arc, is congruent to KL, the arc. Okay? And I also know that angle BAC is congruent to angle KJL. All right? And so again, just trying to reinforce that those three, they play nice together. They all have a relationship to one another. All right, now the next one, next thing I want to look at is going to be this last theorem down here, and that is this. Okay, theorem 11.5. And that's this. Within a circle or in congruent circles, so again, it has to be with the same relationship to each other. Number one, you can write down this. Chords, so that first blank is chords, equidistant from the center are congruent. Okay, chords equidistant from the center are congruent. Now, something I want you to write down in a word-by-word basis is this. The largest chord within a circle is the diameter. Okay? So I want you to definitely have that. The largest chord within a circle is the diameter. Now just underneath that, as a side note, you can make a little note that says this. The further from the center the chord is placed, the smaller the chord becomes. Okay? So again, the further from the center the chord is placed, okay, the smaller the chord becomes. So as you look out here with this one, a length of 36, the closer and closer and closer I get to the center, you can see it gets longer and longer. Now the further from the center I get, you get shorter, shorter, shorter. Okay? So that's visually what I want you to see there with that one. So keeping that in mind, okay, the chords equidistant from the center are congruent should make sense to you. They're the same distance from the center, they have to be the same length. For number two, congruent chords are equidistant from the center. Okay, congruent chords are equidistant from the center. Now it seems redundant, but they both play out in number one and number two down here. Here's what I want you to see. This one's like number two up here, so this one's kind of like this one right here. If you notice, these chords are the same length, both 36. So what do we know about their distance from the center? Well, they have to be the same length as well, and x is going to equal 16. Okay? Now, yeah, I'll just leave it at that. For the second one, what we have here are two chords that are the same distance from the center. So this one, it's a length of 9 from the center. This one's a length of 9 from the center. So what do we know about the length of these chords? Well, they have to be the same length, according to number one. So again, if I make a note, you know, number two is kind of like number one there. All right? And so, I think I'm pressing the button on my pen. If that's true, 12.5 and 12.5, that'd be 25. So the length of A has to be a length of 25 units. Okay? So again, congruent chords means we have congruent central angles. Congruent central angles means we have congruent arcs. And if we have congruent arcs, then we have congruent chords. So that all works together, and then those two parts of theorem 11.5. If any of that doesn't make sense, please come up and see me, but the homework is online for tonight, so I'd like you to take a look at that, and I want you to show me these notes for credit so I can give you credit on that. Thanks, and have a good night.